say right. Heraclite Bikumbu.
Yes.
It's like, whoo! He earned his degree from University of Kent, United Kingdom, and he also has a master's degree in biology from University of Kan, right? Right, that one. Congo. And today he is going to talk about his research done in Lincoln.
Thank you, Dr. Zach. Thank you for everyone who came here. Welcome to my presentation for today. Today we will talk about the response of letters which are in paper to the organic amendment. We see on the title we say about organic, so let us know exactly what it means like organic farming or agriculture. So this is a small background about organic farming. Organic, according to International Federation of Organic Agriculture Movement, is a production system that sustains the health of soil, ecosystem, and people. It relies on ecological process, biodiversity, and cycle adapted to local conditions rather than the use of inputs with adverse effect. It combines tradition, innovation, science to benefit the shared environment and promote fair relationships and a good quality of life of all involved. So, in the other term, we can say it is an agriculture system practiced by farmers that seeks to promote and enhance environmental health while minimizing many adverse effects on natural resources. That's the definition from Hein. And then, in a simple way, we can say that it seems to be different from the conventional agriculture by the way it's trying to minimize input into media and leave the crop growing naturally. Let's talk about technique we found in organic farming. We have the crop rotation, cover crops. And here we talk about Samuel and Jason. We're talking about tillage on the field farm. They have this kind of technique. It should be different. We know how it should be different. Crop rotation, cover cropping, green manure, animal manure, weed management, pest management. So the pest management, they try to avoid herbicide or pesticide by using a prevention technique. So by trying to remove weeds from the field, mechanical or by the hands, so before the weed gets a flower or seeds. So you can now have more weed on when the water is coming. There's another technique like according to livestock management. So we avoid to give grain or drugs to animals on the farm. So that's a way we can avoid to contaminate the animals or the meat animals with drugs and to avoid to spread or to speak pesticide to control the parasites on farm animals. And then the last one is agroforestry. It is a new movement in USA. They're trying to associate trees and the crop in the same field. So we prevent soil erosion or nutrient in the field by using the tree in the farm. So history for organic farming, that is old form of agriculture on the earth. Since the old Egypt, we see people trying to do farming by using animals, and no fertilizer, no chemical fertilizer, or no car or tractor to do the work on the farm. Since the Second War came, so people trying to use, like for example, ammonium nitrate, who's they're using for the munition, but they can transform that to be a fertilizer for the farm. And then organophosphate, nerve gas production, used in the war, it can be transformed to develop a powerful insecticide in the farm. So the Second War came, the new technology, and the people try to change mind to use those techniques to use on the farm. So but before that time, people trying to be very close to the nature by doing a good organic farming. So there is no way to do anywhere else because they didn't know about many technology at that time, so it will be close to organic. But after that, people trying to be looking for a lot of money, and then they use those techniques to improve the yield and then make more money. So organic farming as a movement start in UK, and by Lord Northbourne, who the first one who condemned organic farming in his book, Look to the Land, in 1940. And he has this famous sentence, he said, "We have tried to conquer nature by force and intellect. It remains now for us to try the way of love." So it means that let's have them talk to the land or the field in the way of the love, so no hate the soil and environment. But in United States of America, Rodale in New York City is the one who started to be the pioneer of organic farming by publishing a first magazine saying organic farming and gardening in 1942. Since that time, people trying to work organic farming, but it was very, people trying to use their own money to use the organic farming. And then in 1990, the Senate decided or create or voted the Act Organic Food Production in 1999, and then it was amended in 2005 to create the Organic Food Production Act. So that can regulate the organic farming in the USA. And in the world, organic farming is regulated by Codex Alimentarius guidelines of FOA, Food Alimentation, Food and Agriculture Organization, and the World Human Organization, and IFORM basic standards. So to be organic farming certified in the USA, you should be certified by USDA Organic, and you have this seal on your product. And in the world, you should pass for those IFORM and Codex Alimentarius organization to get your certification or accreditation. So in the world, you cannot just wake up in the morning and say, I'm organic, if you didn't respect any regulation or those principles promoted by those organizations. So since that time, the world came together and make the regulation to have organic farming. So you should respect principle of the health. So everything is related to the health of the human, the soil, the planet, and the planet should be one and not indivisible. Principle of ecology, so we have to care about ecology where we practice our farming. So make sure you don't eradicate biodiversity where you do your farming. With the herbicide, we almost like eradicate herbaceous herb around the field. Even those worms or spiders or beetles or fly or bees in the farm, that's no good. And principle of fairness, to build a relationship between that ensure fairness with regard to the common environment and life opportunities. Principle of care, management, and precaution, so they're thinking about the future generation and the environment. So those the 4 principles which we should take care before we think doing organic farming on the road. So some global statistics on organic farming. So from 2011, we found out that the organic agricultural land in the world, 33% is in Oceania, and then 29% in Europe, Latin America 18%, Asia 10%, North America only 7%, and Africa 3%. So we see here USA or North America only have 7% of people still doing conventional practice of agriculture. And then in terms of the market, USA is the first one because it's manipulating like 21 million of euro. So the amount is in euro, so the money used in euro, no dollars. So 21 million is a lot of money compared to the second one, who's German, has only 6 million only. So you see that USA is the one who who's leading the organic farming market in the world. And then when we see here, even though you see the distribution of total retail sale value by country, USA is also the first one with 44% of organic product. So in Missouri now, we have a local market, and then people are organized by Missouri Organic Association, where small farming, they are together to make this market and this kind of new practice in Missouri. And then the public interest in organic products, produced crops is rising, and many farms are trying to follow the new market generated by public demand. And soon in the summer, we'll see some local markets, like here in Lincoln and Dickinson. We have every Saturday in the summertime a market led by local farmers, small local farmers who come to sell this product from the field to the public directly. But then even in Missouri Boulevard, I think you can see some local market with people selling this product. Those products, I think, some of them, they are very organic because they just come from small farm and then go through to the public without any conservation product or preservatives to keep the product healthy. So why we do organic farming? Organic farming is one of the solutions of environmental problems caused by the conventional farming. So I read in the literature that organic farming is giving solution to soil degradation, soil fertility, water and environmental pollution, biodiversity loss, and greenhouse gas emission. So many data in 2008, we found out that soil carbon was more retained in organic farming by a amount of 981 kilograms per hectare compared to conventional farming, who's only 298 kilograms per hectare. So that's the one solution for climate, greenhouse gas mitigation. And the organic production makes the food more healthy than the conventional production. The objective of my experiment is trying to compare organic fertilizer to one mineral fertilizer and observe the relation between the crop, between the crop, the three vegetables produced here. And then the question we should answer here is, will organic farming take over conventional farming in regard of environmental problem and then the world population growth? Now we're trying to answer this question when we have our result. So let's go to the material and then see what we use in the material to do the experiment. We use for organic farming soil. That is organic soil. And organic fertilizer, we have cotton seed meal, dry blood, Zoom garden. That is the manure, or for chicken, poultry manure. And then the mineral fertilizers, so the chemical product is 13-13 ratio. Vegetable, we use lettuce, switchard, pepper. Container, we use pot, saucer. And then all the experiment was conducted in greenhouse of Lincoln University at Dickinson Center. So let's talk about a little bit about fertilizer. We use like 3 organic. We have red blood that has a ratio of 12:0:0, so 12% of nitrogen. And then cottonseed has a ratio of 2:6:1, 6% of nitrogen, 2 of phosphate, and 1 potash. Zoom garden food, that's organic plant food, has a ratio of 4:3:2, and that's a poultry manure. And the last one is a mineral NPK, what we say 3:3 or 13:13 ratio NPK. That's the main fertilizer we use on our experiment. So, and then to apply the fertilizer on the pot, we did a calculation on base of ratio saying that 4 kilograms of nitrogen actually by 907,185 kilograms of soil. So that's used on the pound, it just transformed to convert to kilogram. Then our pot is contain 850 grams of soil. So we have to figure out how much we need for that quantity of soil, that volume of soil. And then we found out it is 0.0425 grams of nitrogen we need for each pot. Regarding this quantity of nitrogen in the pot of 850, we need to calculate for each fertilizer which quantity exact we need for in regard of percent of nitrogen in the composition of fertilizer. For the cotton seed, we found it's 0.5 or 708 grams cotton seed in the pot, and dry blood 0.354 grams. And the Zoom garden food, we use 1 gram 0.63 of that product in the pot. And for the mineral fertilizer, we use 0.327 grams of that product in the pot. The 3 type of vegetables, we use switchard, we grow switchard, that's beta vulgaris, sweet pepper, capsicum annuum, and the garden lettuce, Lactuca sapula. So this is the picture for the crop we did on the greenhouse. So the plant, you see the pot, then the stem and the leaves of the plant. This is the environment where we conduct our experiment. And then we have, the plot was not standing on the floor. The plot was on the bench. And we have 2 benches. So the plot, the next slide, you can see how, you can see, this was the layout of the bench. You see here, on each bench, we have 4 blocks for 4 replication. In each replication, we have 5 treatments. We have 5 treatments, 1, 2, 3, 4, 5, and then 3 types of vegetable, 1, 2, 3. But in every block we have 15 pots. That means in one bench we have 60 pots. Times 2 benches, we have 120 pots. Let's come back to this slide to show that exactly how we proceed to have the pot to be filled up. We have 850 grams in the pot, and then we made a treatment of 5. And the first one should be the control. There's no treatment in the pot. And the second one, copper seed, dry blood, garden food, mineral, fertilizer. We bring the pot to the water saturation. After that, the next day, we sow the seed in the pot, in the 3 vegetable crops, which are the green and switch are. And the experiment design is a randomization complete graph. The plots are randomly when you come back here. So this plot or this pot, they are not. It is not any order on this pot. It's just random. So we can find fertilizer like cotton seed here, the other one this side, or mineral here. That's so very randomly. So that's why we call that randomization complete graph. And then we have 5 treatments for fertilizer, variable vegetable 3, and replication 8. And 5 treatments times 3 variable times 8 replication, we have 120 pots measured. Data collection is about the growth parameter. Growth parameter, yes. Height of the plant, number of the leaves, plant fresh weight, plant dry weight, leaves area, root fresh weight, and root dry weight. And these are the LI 3100C machine. They help us to measure leaf area. So this is our result for the first month. So when we plant our crops, we wait to have the first germination. After germination, we count 1 month and we start to record to harvest the plant. And then this is the result for the first month when we harvest the plant or the crops. And then we can see some trend already. Mineral fertilizer has made the first difference to have the higher length of the plant. The dry blood has the higher number of leaves, and the mineral again, the plant dry weight, the highest, and then plant fresh weight, mineral, and root dry weight is a mineral fertilizer. And cotton seed improved in the root fresh weight. So in the vegetable, between vegetable, we found that sweet chard has the highest means of all parameters here. And then, yeah, yes. But if you look at on the analysis of the variance, yeah, we can tell that according to the fertilizer, there is no significant difference between those differences we see here because their P value was greater than 0.05. But after 4 months, because between 4 months and the first month, the trend was similar to the first month. So we just jumped to the fourth month, where we found out a big difference now, because we see that the fertilizer, the good trend of fertilizer on cottonseed meal has the highest height, number of leaves, and all the perimeter till the area leaves. And then the green, between the vegetable, we have the green lettuce who has the higher parameter of growth. If we go to analyze the variance between the fertilizer, we can tell that the difference observed on the fertilizer is significantly different because the p-value is less than 0.05. And then we can tell for plant dry weight, plant fresh weight, and then the last one, area leaves for the fertilizer, and then that fertilizer is a cottonseed meal. Between the vegetable, we see the difference between, well, they are very, first of all, there are different type of spaces, so that's normal to have a difference. The p-value is 0.00. And the green lettuce, that's the one has the, I improved the difference between them. So how we say all growth parameters were significantly affected by vegetable type from the first to the 4th month of growth. However, for fertilizer, the number of the leaves, plant fresh weight, plant dry weight, and leaf area were significantly affected by fertilizer. And then we say that the cottonseed was the one has the first difference in the 4th month of study on. So this is some graph here. We can now show up the pack of the fertilizer on the top, the cottonseed here as the histogram of red one has the highest area leaves. So the first area of the leaves is bigger, very high with cottonseed. Then he has a fertilizer. Even on the height, he has the highest number. Number of leaves is higher, and the plant dry weight is higher too, and the plant fresh weight is higher too in the biomass. So in this step, you can say cottonseed has a good impact on as fertilizer on the growth of the plant. If we compare the vegetables themselves, we see that the green lettuce has the highest surface area or leaves area, and then height, number of the leaves, plant dry weight, and fresh plant weight. So that's green leaves are the high biomass produced during this experiment. In this step, we can discuss that among the vegetable, green lettuce has the highest growth compared to the other vegetable. I would say lettuce has the shortest cycle of vegetation. That's then the other and grow fast. So as the cycle of the green lettuce is very short, it's trying to maximize the time to get more nutrient and it grow fast, and that you can see the big difference between all of them compared to the pepper who the cycle of vegetation is long, then it's taking time to grow. The cottonseed as a fertilizer, 6 to 1 give better growth than NPK restricted. We're expecting to have mineral NPK 13 have more, but we see something different here. But some like Meridate and sulfate found the same trend in this experiment, trying to, because they found out the organic farming has having more impact on the heat to that experiment. But testify in 2004 found that mineral fertilizer improved more growth than organic in experiment on the monograss. Use the monograss like a crop. So in summary, we can say organic fertilizer affects plant growth more significantly than mineral fertilizer in terms of number of leaves, plant fresh and dry weight, and leaf area. In this step of study, it seemed that organic production could be very interesting for the crop yield. The trend of our first conclusion show that there is a significant difference between treatment. So organic fertilizer tend to be heavier like a mineral fertilizer in terms of response yield of all three vegetables. Organic farming may take over the conventional farming, but it's too early to confirm since most studies are recommended to implement in order to come with more results. And the recommendation, you can say, more studies need to be conducted to confirm this result. Especially, we recommend to do organic farming in the field, in the real field, instead of doing it in the greenhouse. We go to the field or maybe in the high tunnel, so we can we take account all factors like biodiversity on the field, the light, or grain, those kind of factors compared together can make some difference and then be significant than doing it in the greenhouse. And then those results compare each other will influence the better decision to promote or not the organic production in regard to the same constraint. The world population growth as it was found, because some study was found say that the population is still growing, and then we asking people to produce 2 times or twice the quantitative amount for the food for the population. So that's the big constraint the organic farming has, because in terms of production, we still organic farming is struggling to find out how the best amount of yield we need to feed the world. So some of our main references I used from presentation. We have those names and reference. That's it.
Again, we have 15 minutes for answering questions. Anyone?
Students first, right? Yeah. Students first.
Today it's open to anyone. Anyone. Go ahead. Thank you.
First.
Oh, go ahead.
Is there
Go ahead. I see you. Go ahead.
Okay. Looking at your presentation, the first moment when you are talking in general about organic farming, and then you showed a plot, I think it's a pie plot, where Africa comes as a last in that graph. I want you to tell us what would be the difference between the traditional farming practice in Africa and probably in many other tropical areas where they don't use fertilizer at all. They rely on Mother Nature. Okay? And from your definition, you say that in Africa they use only 3% of that organic farming.
Yeah, if I can give the answer, so these data come from one organizational international federation of organic farming or movement. So those guys, when they do their research, they take account data they have to produce. The organic or the type of agriculture now in Africa is not documented. So they don't have any data to say anything about it. But I know, me, personally, I know, I'm from there, I know that people that relate to the nature, and then they don't use any chemical to produce food. But if there's no data, how can it be published? That's the big problem. So even if we go to literature, we will say the same. There's no very data. Only Uganda and Tanzania, maybe Tunisia, has a system of state system where they have data collected to who they can say anything. So maybe from those 3 countries they get those data and they have that's percentage for 3%. But I can say I know that people are trying to live organic.
Okay, I can take the answer. I think it's good because if there is a lack of data, but in reality, to practice organic farming. Because when I see some people here doing, you are quoting farmer market just because they don't use organic fertilizer or pesticide, they say they are doing organic farming. And it's what people do in most of the tropical countries.
So just to add, normally when they do this type of graph, they should not put Africa there. Because here they're comparing, traditional, chemical-based versus organic here, because there are few people do organic variety. In Africa, probably most people use organic than the other one, so they should not really put Africa here. They should really, because Africa is 97% organic and maybe 3% mineral. It's supposed to be, they should not put Africa here.
I was surprised. Okay, I have some more concern that not very fair.
Well, another time.
Yeah.
You can go
10 more minutes.
Okay. Okay. This is just a suggestion I want to make to Hera. You need to be consistent in your presentation, the way you are using data, the units, and so on. In the same presentation, you are using kg. Sometimes you use with a capital letter, okay? Some other time, yeah. And it's not like this. Really, it's K, small, okay, letter, kg. The same thing for hectare. It's minuscule, not a capital letter. Okay, and there is one table where you
can run this recommendation.
Yeah.
You can leave it to there.
Okay.
It's better.
Okay, it's better.
One question I have is, how come you have an NPK 1313 and you have a cotton seed 621, I guess, but still you have more, better growth in that year. Cotton seed was the best, giving 621. Yeah, but at the end you found out that cotton seed is better than mineral fertilizer. Why?
Yeah, This was our first experiment on the field. The first year, that's what we found. So why this is possible? I think
maybe there are some other element in that cotton seed.
No, maybe some factor. Maybe some factor will come in account that we didn't take care of. We didn't talk about. We didn't find it about that because many factors of soil properties can be studied and know exactly what's going on. Because
what about your irrigation? Don't think maybe the water you provide may not be there.
So what I provided was the same everywhere because I was measuring my water using the beaker. So,
but when you take a yellow fertilizer, you put water, what will happen?
If I put fertilizer,
I mean, if you have your pot, you put some fertilizer, and you water it frequently, what will happen?
The water will leaking?
Yeah, what like water, but what happened to the fertilizer?
About fertilizer, the fertilizer will be going down the pot.
Okay. So that may not be an explanation?
Yeah, but we didn't do any measurement for maybe on the roof to see how the root, the length of the root can be maybe one of the part of the solution to know exactly.
No, what happens is when you have a mineral fertilizer, put water, the reaction is rapid than the cotton seed. Cotton seed probably is a slow release fertilizer.
Yeah.
As you water frequently, the nitrate goes up. Yeah, they wash it off. That's what happens. But the other one, since it's slow release, it remains, more time. And by the time the plant grows, but the mineral one goes quickly because of the frequent irrigation. So next time probably, if you recall, one of the ways should be that if somebody in the experiment, you can always take the leachate, measure the nitrate coming out. We're going to see that on the mineral, we're going to see more nitrate than the other one.
But, Dr. Nkongolo, if that were a field, I think you would be more right. But in a pot, where does the nitrogen go?
Well, you let water.
I'm sorry?
Here, you are going to the bottom.
Yeah, the water stays on the bottom and then it goes back up in the pot little by little.
Yeah, he didn't water on top, he watered below. He
You
watered the
water
saucer.
below or?
No.
No, you water the top.
Where do you want to make the separation? What do you call it?
Yeah.
You didn't water from the top, right?
Yeah.
So mostly your NPK, the opinion was that water you have.
Yeah.
So what you did with that water in the saucer, you throw it away?
No.
Well, you evaporate.
I just leave it there, then
And
it's a couple of seconds.
Yeah, that's what I said. So where does the nitrate go in that case?
Well, because it doesn't go back because what happens if you water, you don't maintain the same level of water. At some point, maybe a 5 centimeter on top of the pot will not be saturated.
Sure.
If the bottom saturated, the root doesn't reach there, so that's why that's the issue that the roots stay at the top centimeter, but the contact is between the saucer and maybe the middle of the pot. So those roots do use the nitrogen. However, the other fertilizers will stay there, so it's not really, that's why you see that. And if you do that over the first 4 months already, you're going to have this spend almost all your NPK. But the other one stays, so that's the explanation if you go somewhere else.
Simon, have a question?
Yeah, I was just going to ask about your replicates, the procedure. You said you had 4 replicates.
8.
Okay, 8 replicates. That is 4 on each bench. Oh, okay. Just to be clear.
Anyone? Any question?
Just a question about the benches. He mentioned, looks like he appreciated the fact that he used the bench, but he didn't give any explanation about using bench instead of the ground.
In the greenhouse, that's the way the greenhouse is modeled. So we have the bench. We don't put the pot on the floor. Is a bench.
Yeah,
To
it's
keep
the
the
way,
bench.
but I didn't understand why you specifically say, okay, we have it here on the bench, okay? Maybe you wanted to say something, you didn't.
No, maybe I'll contrast this one for my recommendation, saying that instead of putting the stuff on the pot on the bench, let's go now on the field and the ground and see how it will react. That's why I mentioned to say that, oh, not here is on the bench, but if we make improvement by doing it on the ground or in the field, maybe we will get more difference and then say something else. That's why I mentioned this one, so people can know that using the branching on the ground.
I guess that's the system of the greenhouse.
Yeah.
The greenhouse is open, not all.
Yeah.
Actually, normally you should, after this study, you're supposed to go to the, you're supposed to build a root house and do that on the, that's the whole idea. So this was only the first step to test, then go outside, but the man is there, the room never been built, you know the system.
I don't know this.
The system there, man is there, root house until today. Anyway. Okay.
Okay, that's all for today.
Thank you.
Thank you.
So you have, you know, you get the 101. Yeah.
Yeah.
You see,